So we have another ellipse drawing mechanism from this book, Mechanisms for the Generation of Plane Curves. This time, figure 173. I'll take a look at that mechanism. Share my screen of GXWeb, free browser-based symbolic geometry system. Now, for doing mechanisms, I like to have my axis there that allows me to attach things to it. The first thing I want to attach is this line is a vertical line, a vertical part of a mechanism that can slide backwards and forwards, left and right. But first of all, we need to make it vertical so we can constrain it to perpendicular to the x-axis. Now, the mechanism has got an arm which comes out that direction, and another which comes out horizontally from there. So this is attached by a little square slider block which lets it slide in and out but keeps it perpendicular to here. And this point B needs to lie on that line, so we can make that happen. Okay, so now as we pull this around, our mechanism does something that looks like that, but of course this could stretch because we haven't constrained its length. So let's do that. Make that A, and we can make this length B. So now these are going to stay fixed, and that gives us more what our mechanism is going to do. We're going to drive it with an angle. So stick this angle here, theta. Again, we can drag that and I'll just change theta. Theta has a unique situation here because we tend to use that as a variable, and x is another one. It by default is unlocked. A and B are typically parameters, and they're by default are locked. However, you can lock theta, in which case you could not drag it. Okay, so the thing that's our pen that's going to draw our ellipse is there at that intersection. And if we now create the locus, as theta varies, we have what certainly looks like an ellipse. Let's check that it is. Find the equation of K0. There we see not an ellipse, but it's a relatively straightforward equation. We can see it's the principal axes are in fact A and B, and we can see that why. There's A and there's B. Now, that's our mechanism. The book ends with an interesting observation, which is this: if we now proceed to draw an auxiliary mechanism, now to prevent this mechanism accidentally sticking to the axis, I'm going to hide him for a moment. So I've got an auxiliary mechanism here with particular lengths, this length being A plus B over 2, and this length being A minus B over 2. Let's just grow B a touch, or shrink it a touch rather, just so we've got a little bit more separation here. Now what I'm to do is to put a point on that line, another point on the line, both of which are A minus B over 2. So I'll copy that from F. So paste that in there and paste that in there. Now point H is not actually lying on the line, so we have to make that happen using our incidence constraint. Now under these two specific points, as we move our mechanism, we see that they in fact move along the axes. And so this relates this mechanism quite handily back to the trammel, this line from H to E, effectively being the trammel.